But we're not done yet, because it's my pleasure today to announce Mac OS X. This is, I hope, also going to blow you away. We are announcing Mac OS X here today. I'd like to go over the goals for Mac OS X. First, we are going to have a single OS strategy at Apple. We're not going to have a dual or a triple or a quadruple OS strategy like some others. We're going to have one OS. And that's very important to us. The second is the Mac OS needs state-of-the-art plumbing. We need the best operating system kernel technology, the best internet networking in the world. Right? We need the best plumbing of any operating system out there. Third, we need killer graphics. Almost every app depends on graphics, whether it's design and publishing apps for our pro customers down to things that we use every day. We need killer graphics in this system. And we need to design it for the internet from the start. We need to design it in a way that most users who are always plugged into the internet get full benefits. We need to design it in such a way that we use internet standards throughout, and we've done that. And we need a gentle migration, because we have 25 million users using our current generation operating systems. So these were the goals for Mac OS X. But to sum it up, it was make the next great personal computer operating system. Now, there's going to be a 12-month rollout of Mac OS X. You can't do these things overnight. It's going to be a 12-month rollout. So we are announcing it today, January 2000. Our developers have already had a few betas of the software. They're going to get another pre-release of the software at the end of this month. The final beta will go out to developers this spring. Mac OS X will be on sale as a software product starting this summer, and we will be preloading it on all machines a year from now. So that is our rollout strategy. Now I'd like to go through the architecture of Mac OS X with you. To start off with, we need a kernel. And that kernel we call Darwin. Darwin's amazing. It's a super modern kernel. And it's got protected memory, preemptive multitasking, modern networking, all the things you'd expect, done in a very elegant way. And it's very Linux-like, very much so. It's got free BSD Unix, which is the same as Linux. So it looks almost the same to developers. It's got a mock microkernel, and it's completely open source. You can go to Apple's website today and download it, as 75,000 people already have. It's completely open source, and we're getting a lot of help from the Mac community to make it better and better and better. So we're extremely excited about Darwin. The next layer on top of Darwin is killer graphics. We've got three components: our 2D, which is Quartz, our 3D, which is OpenGL, and our media layer, which is QuickTime. And they're all seamlessly integrated right into the operating system. So let's take a look at Quartz. Quartz is PDF-based. What does that mean? You know when you go to the web and you see PDF documents, and you read them with Acrobat, this great technology invented by Adobe? Well, that technology is now at the core of Mac OS X's graphics. So you can image PDFs instantly. We have on-the-fly PDF rendering, anti-aliasing, and compositing, which will blow you away, built at the core of the OS. So now all applications get this for free. And we have built-in transparency into the model. And I'll show you that in a few minutes. Our OpenGL 3D standard is the most widely supported 3D standard in the industry. It's very advanced, and we have full hardware support for it, built in, again, to the core of the operating system. And obviously, QuickTime for digital video and audio, live internet streaming, internet standard, 33% market share, built into the core of the OS. So those are our killer graphics. The next layer are our APIs, the things that our developers program to. And there are three of them in Mac OS X: Classic, Carbon, and Cocoa. Classic, and the reason for this is to provide a gentle migration for people from the left to the right over time. Mac OS 9. Classic runs Mac OS 9 apps as is, without modification. So you can run your Mac OS 9 apps right on Mac OS 10. You do not get all of the new features, however, because it's impossible to do technically. But they all run, and they run well. Carbonized apps get the new features. Now, what's a carbonized app? It's something that takes a developer a few months, 1 to 3 months, to carbonize their app to get it ready for OS 10, and all of a sudden it springs to life with all of the new features of OS 10. And the third API is Cocoa. It's completely different. It's fully object-oriented. You can write applications in Java or other object-oriented languages and get all of those benefits. So developers can choose any one of these they want. They can run the existing apps in Classic. They can spend a very short amount of time carbonizing their app to get all the new features, which we think everybody will. Or for new applications, they can write them in Cocoa and get all of the benefits of Apple's incredibly advanced object-oriented technology. So that is the API layer. So this is the architecture. Except there's one more thing. The one more thing is we have been secretly, for the last 18 months, designing a completely new user interface. And that new user interface builds on Apple's legacy and carries it into the next century. And we call that new user interface Aqua, because it's liquid. One of the design goals was when you saw it, you wanted to lick it. And so we call it Aqua, and this is the architecture for Mac OS 10. And we are incredibly, incredibly excited and pleased with how this has turned out. Now, when we talk about user interfaces, let me show you. This is it. No. This is what started it all, right? The original Macintosh in 1984, 512 by 384, dots on the screen, black and white, kicked off a revolution. And we saw others follow in the late 80s. This was Windows 3.1 in the late 80s. And Apple followed up in the mid-90s with the current user interface called Platinum, still the best thing out there. And then this is Windows 98, which obviously came out in 98. So these are the user interfaces out there. They're all credible. They all work. How do we take this to the next level? Well, let me show you a few slides on Aqua, and then I'd like to demonstrate it for you. So this, you get a little feeling for what Aqua may be like. So I'd like to just start off, you know, when you design a new user interface, you have to start off humbly. You have to start off saying, what are the simplest elements in it? What does a button look like? And you spend months working on a button. That's a button in Aqua. This is what radio buttons look like. Simple things. This is what checkboxes look like. This is what pop-up lists look like. Again, you're starting to get the feel of this, a little different. This is what sliders can look like, right? Now let me show you Windows. This is what the top of Windows look like. These three buttons look like a traffic signal, don't they? Red means close the window, yellow means minimize the window, and green means maximize the window. Pretty simple. And tremendous fit and finish in this operating system. When you roll over these things, you get those. You see them? You know? And when you are no longer the key window, you know, they go transparent. Right? So a lot of fit and finish in this. In addition to the fit and finish, we paid a lot of attention to dynamics. Not only how do things look, but how do they move? How do they behave?